Good day to you. This is teacher LELAND. Alejandro, we're going to do special right triangles. Right triangle with the three angles 90 and then 45 and 45. And then the other one is another special right triangle with 30, 60, and 90. So we're going to study the examples for these two special right triangles. Now, to start with, we're going to see first the theorem. Let's check the theorem first from the book. Let's check this out first. Okay, here's from the book. Theorem 8.6. It's the 45 degrees, 90 degrees theorem. And it says there in the 45, 45, 90 triangle, the length of the hypotenuse is square root of 2 times the length of the leg. Okay, we can actually show this to you by using a drawing. Okay, let's start with the 45-45 triangle is something like this. There. You can actually see here the 45 degrees and another 45 degrees and 90 degrees. And we have the two legs called sides. This side's called legs, okay? And these are equal. And the hypotenuse is the longest side of the right triangle. It's always opposite the 90. It's opposite the 90. So this hypotenuse is equal to square root of 2 times the measurement of the leg, where the leg are equals. They are equal. All right. Let's have the next one. We should try to see the other one. Let me just show you the other theorem. Okay, here's the other theorem. Let me put it lower there. Okay, from theorem 8.7, you have the 30 degrees, 60 degrees, and 90 degrees theorem. So 30, 60, 90. In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. And the length of the longer leg is square root of 3 times the length of the shorter leg. Now, what do we mean by this? So let me get the drawing for this right triangle. Okay, here's the special right triangle so that you can see which one is the shorter leg, which one is the longer leg, and which one is the hypotenuse. Now, there are three angles in this triangle. The 90 being the largest value is opposite the longest side, okay, there. That side, of course, is opposite the 90. So the longest side, which is called hypotenuse, for hypotenuse, the H, is the longest side. And it's opposite the largest angle, 90. The next size is the 60. This is 60 degrees. That's a 60-degree angle. And that is opposite the longer leg. So this is the longer leg, this one. That's the longer leg. And then, of course, the shortest leg, the SL, is opposite the smallest angle there. It's the 30. And it's opposite that particular shorter leg. So in a right triangle like this, the smallest angle is opposite the shortest leg. And then the next size, which is 60, is opposite the longer leg. And then, of course, the longest side, which is hypotenuse, is opposite the right angle, the largest angle in the right, in this triangle. Now, we're going to use two formulas only for this 30, 60, 90. You can see the hypotenuse is equal to 2 times the shorter leg. There, that's your formula. So that means if you double this shorter leg, that will be the measurement of the hypotenuse there. Now the second formula is longer leg. We use the LL is equal to square root of 3 times the shorter leg. So this side that you can see, which is the longer leg and opposite the 60, okay, opposite the 60, that's the longer leg, is square root of 3 times the shorter leg. That's why you have that particular formula. Longer leg is equal to square root of 3 times the shorter leg. Now we're going to apply these formulas in our examples, okay? So don't forget the formulas there. Okay, so we shall solve the examples in the other screen. We should be able to get that particular screen over here, which contains the problem sets, okay? There. Here's the first one. Find the missing lengths, okay? And you can see the drawing. It's 45, 45, 90. So if this is 45 and this is 90, then this must be 45, of course, to make the right triangle with the 180-degree measurement for interior angles. So these are the given. This 10 here is a leg, and that is supposed to be equal to this other leg here. So we can right away solve this, and the value of y here must be equal to 10. So if we're going to solve this, we shall copy the problem and the given, and according to the instruction, leave your answer as radicals in simplest form. So let's try doing this, and let me just write first the problem in a clear paper. So this is for number 1, and this is your right triangle. Your given is 10. This is y. This is the 90. This is 45. This is x. There. And so let's see the solution using the other screen, where you can see how I write it. Okay, so we just copied the figure in the other side, and we have this particular drawing. Now, this must be your shorter leg compared to the hypotenuse, and so we can actually have leg is equal to y, and this is equal to number 10 there. So the formula actually here is hypotenuse is equal to square root of 2 times the leg. Our leg is 10. So we have square root of 2 times 10, or we usually write this 10 square root of 2. And we have the answers. For this particular triangle, this must be equal to 10, and this must be equal to 10 square root of 2. There. All right, let's verify. Let's verify our answers. So just remember, our y is 10, our hypotenuse is 10 square root of 2, and you may be able to see that in the other screen. So let's check that out over here. There. So we have 10 square root of 2 for the hypotenuse, okay, here. And of course, the other leg is equal to the other leg. They are supposed to be equal. So that will be for the first number. Let's proceed to the second. Here is number 2. And we can actually enlarge that. There. And so we shall get the figure. Let me just put it in our solution paper. This is 45 degrees. This is V. This is U. And this is 8. And this is 90. This is another 45, 45, 90 triangle. Now let's go to the other screen and let's visualize it. So that will be in the other screen where we're. All right, let's move to number 2. Okay, here is our number 2. Now, you see a right triangle here with 45, 45, 90. This is supposed to be also 45. There. And this is supposed to be 90 by the symbol. There. Now, we're asked to solve for the other leg here, which is by the theorem. You don't have to solve this. This is by inspection. Your V must be equal to the 8, because the two legs are always equal in a 45, 45, 90. Now, you only need to solve for the hypotenuse, which is the U, and which is equivalent to the product of square root of 2 and the leg. Now, in this case, this is V. So U is square root of 2 times 8. And we usually write this, the integer first, times the radical. There. So that must be the measurements. And the answers are, of course, the other leg is 8. And the hypotenuse is 8 square root of 2. And we can verify that in the other screen. Let's go back to that particular screen. Okay, so it must be this one for number 2. Okay, let us show the answer there. So we have 8 square root of 2 for the hypotenuse U, and V equal to 8, which is the other leg. The two legs are always equal for this triangle. Let's have another 2 more examples for this triangle before we proceed to the 30, 60, 90. All right, let's have number 3 over here. This is number 3, and our 45, 45, 90 triangle is drawn in a different manner, but you don't actually get confused by the drawing. As long as you know the theorem, this is 45 degrees, this is 90, the hypotenuse is given. We're about to solve for the legs. There, let me just proceed to the other screen. Okay, so it must be this one. Okay, here's our number 3. All right. Now, this is actually the given and number 3 in the other screen, and I placed in the paper, and you can see a 45, 45, 90. If the given is a 90 and a 45, we're sure this is also 45. Remember, any triangle is having an interior sum of 180, interior angle sum. So this must be the 90 there. And so in here, this is the longest side opposite the 90. And this is your hypotenuse, the 2. And this Y is a leg, and this X is a leg. Now, remember our formula. The formula is actually hypotenuse is equal to square root of 2 times the leg. Hypotenuse is square root of 2 times the leg. Now, what we have here is the hypotenuse. This is the 2. That's our hypotenuse. It's opposite the 90. You can see it's opposite the 90. So that means that's the longest side too. So we shall use this formula and then substitute the 2 in the h there. So you may write here 2 is equal to square root of 2 times the leg, where the leg is actually represented by the variables x and y. So by using this formula, we can actually solve for the L. And so in an equation like this, we will proceed by division. By using this equation, we will proceed by division of the by the number beside the variable. In other words, we're going to divide this by the square root of 2. There. And this cancels out, and we have leg is equal to 2 square root of 2. Now, remember in algebra, we don't usually write a radical or a square root at the denominator. So we're going to change this such that the square root of 2 is not there. And we shall change this by rationalization. So leg is 2 over square root of 2. You multiply this by square root of 2 over square root of 2 there. And so square root of 2 times square root of 2 becomes square root of 4. We multiply the denominators. So this will be square root of 4, which is actually exact. Later, that will be 2. Now, the denominator, which is just the product of these two, there. And we continue like square root of 4 is exactly 2. And this is 2 square root of 2. You see the number 2 divides by the number 2. And the final answer is just square root of 2 there. So that must be the answer. And this goes to the x and y. Remember, in this triangle, the legs are equal. X equals y, and that's equal to square root of 2 there. So remember the answer, it's a square root of 2, and we shall be able to verify that in the other screen. So let me just show you the other screen back, and let's find out the answer. Our answer is supposed to be square root of 2 there. You can see the x is square root of 2, and the y is also square root of 2, as I have computed in the other side. Let's add number 4. Okay, this will be our last example for this 45, 45, 90 triangle. And then we will be continuing with the other type. And so let's continue with number 4. Let me just draw the figure of the paper. This will be for number 4. And we have the right triangle over there. The given leg has a value of 9 square root of 2 over 2. The other leg V is unknown. And of course, this is the 45 degrees. And this is the 90. And we have the U. That is actually the hypotenuse. Okay, you'll be able to see the solution after a little while. So let's proceed to the other screen. Okay, here it is. All right, here. So this is the number, for example. Okay, excuse my drawing. All right, so we have exactly what we have in number 4 in the other screen. And you can see the given is a leg. This is actually a leg, okay? This is a leg. So if you may write that, that's a given leg, 9 square root of 2 over 2. There. So this must be the given for this particular problem. Okay, you're asked to get the V, and you're asked to get the U, which is the hypotenuse. All right, V, of course, we can solve right away. That is exactly equal to 9 square root of 2 over 2. So the answer for V, let me just put it here. The answer for V, that's exactly equal to the other leg. That's 9 square root of 2 over 2. There. Now, how about the U? The U is actually the hypotenuse, okay? The U is the hypotenuse. So the formula for hypotenuse is square root of 2 times the leg. And we know the leg is this. So we can just substitute it there and compute and simplify. Hypotenuse is square root of 2 times 9 square root of 2 over 2. Now in algebra, you can right away simplify this. So you can actually multiply the square root of 2 and square root of 2, giving you square root of 4. So this will become 9 square root of 4 over 2. And we know square root of 4 is exactly 2. So we have 9 times 2 here and 2. And the 2 divides, the answer is 9 for the hypotenuse. There. The answer is 9. Okay, that goes to our number 4. So remember the answer, it's the other leg 9 square root of 2 over 2, and the hypotenuse U is 9. So you can write down here U equal to 9 there. So these are the required answers, and you can verify this in the other screen. Just have to remember your answers. So let's check this number 4, and let's see. It must be on the other side, and we shall verify the answer. And let me just adjust it there, okay? So U is equal to 9, that's the hypotenuse. And V is the other leg, which is equal to the other leg there. And so we're done with the 1 to 4 examples, which is the 45, 45, 90 right triangle. We are now ready to do the other 4 examples for the 30, 60, 90. So let's see our next examples. And let's read the problem. Find the missing side lengths. Leave your answers as radicals in simplest form. Now, radicals are square roots. Those are the square roots that are involved in our answers. So this is number 5, and we shall try to continue. And let me just put the problem over here. Okay, this will be our 30, 60, 90 triangle. Let me just copy first exactly the drawing there and proceed to the other screen for the solution. And this will be over here. Okay, there. All right, here is our number 5 example. Now, as you can see from my drawing, this is the 30 degrees and this is the 90. In any triangle, the total is 180. This must be the 60. There. And so you can always identify the parts, okay? Opposite the 60, which is the middle size angle, 30 being the smallest, okay? 60 is the middle size, and this must be the longer leg there, okay? This is the longer leg. There. And then, of course, opposite the 30 degrees, the smallest angle, opposite this, is this side. And this must be your shorter leg there. And of course, opposite the 90, the hypotenuse, the longest side in a right triangle. This must be your H. Okay, so we're now going to use our formulas, okay? And we shall recall the formulas that we had. Of course, we have the hypotenuse. That's supposed to be 2 times the shorter leg there. And we can use this because we have the hypotenuse. We have the hypotenuse over here. So 8, substitute, direct substitution, 2 times the shorter leg there. And just one more step, and we have the size of the shorter leg. This is by way of division. So we have 8 is equal to 2 times the shorter leg. We shall divide this by the number 2. And this cancels out. Shorter leg is equal to 8 divided by 2 is 4. And we have shorter leg equal to 4. There. Now we have 2 sides of this right triangle. We're now ready to solve for the longer leg. We have a formula for the longer leg, okay? And that formula is longer leg equal to square root of 3. Remember, square root of 3 times the shorter leg there. And so longer leg is square root of 3 multiplied by shorter leg. We already know the shorter leg, it's 4. So here's our answer for longer leg. And we have to write it using the integer first. So longer leg is 4 times square root of 3. And we have the answer for the longer leg. And so you can write this using the given letters so that the shorter leg is for n. So n is equal to 4. And your m being a longer leg, your m, okay, that's 4 square root of 3. So this is equal to 4 square root of 3 there. All right, time to verify the answer. Just remember your answers. Longer leg is 4 square root of 3. Shorter leg is 4. All right, we shall verify this in the other side. And that must be over here. We're doing number 5 now. Okay, what's the answer? All right, our m is 4 square root of 3. Our n is 4. And that's we have in the other screen. Okay, let's proceed with number 6. Okay, here's number 6. All right, here's the figure. Okay, we can actually enlarge it like that. Okay, now we can make it large this way, and we shall continue with number 6 solution. This is still 30, 60, 90. So we have here 6, and this is the right triangle. We have a 60, we have a 90 degrees. The side 8 must be the shorter leg. We're looking for the hypotenuse U and the longer leg V. This is for number 6. Find the missing side lengths. All right, let's go back to our paper. We shall do it over here. Okay. And here's our reproduced drawing. We're looking for hypotenuse U and a longer leg V. Again, how do you know which is longer leg and which one is shorter leg? Which one is hypotenuse? Opposite the 90, that's hypotenuse. And opposite the 60, this is your longer leg. And of course, if this is 60, the other angle here is the smallest, the 30. There. And opposite this smallest angle, that's your shorter leg. There. So actually, the given that we have here, the given is the shorter leg. There, 8 units. So therefore, if you have the shorter leg, you can right away solve the hypotenuse and the longer leg V. Let us start with the hypotenuse. Okay, U is the hypotenuse, which is equal to H, which is just 2 times the shorter leg. 2 times the shorter leg. So our U is equal to 2 times the shorter leg, which is 8. And so U is 16. There. Next, we're now going to solve for the longer leg V. Okay, longer leg V. Okay, V is equal to the longer leg, and is equal to square root of 3. Okay, square root of 3 times the shorter leg. There. And so, direct substitution. This will be square root of 3 times our shorter leg, which is 8. And we write this using the integer first. So this is 8 times square root of 3. And this goes to our longer leg, which is the V. There. Okay, so these are our answers for our number 6. So 16 and 8 square root of 3. All right, let's verify. Let's see our problem set. And should be able to check the answers over here. There. So the hypotenuse is 16 and the longer leg is 8 square root of 3. Let's do number 7. Okay, let's have number 7. Okay, here is number 7, another example of 30, 60, 90 right triangle. Okay, and let me just write the given. This is number 7. Let's write the drawing. And we have 30 degrees over there. And we have 3 square root of 2. We have the 90. We're looking for the leg Y and hypotenuse X. There. Okay, let's change screen. Let's move to the working screen. There. Okay, This one goes to number 7. Okay, number 7. Okay, let's see what we have here. We have a 30 degrees and a 90. There. 30 degrees, and by this symbol, this one is supposed to be a 90. There. Now let's examine the sides and as related to the angles. If this is 30, this must be 60 over here. There. And so we can identify now the hypotenuse, the shorter leg, and the longer leg. Okay, again, opposite the 60 is the longer leg. Opposite the 90, that's hypotenuse. There. And opposite the smallest angle, 30, opposite that, that must be the shorter leg. There. Now we're ready to solve. Our given data is the longer leg. The longer leg is 3 square root of 2. So the way to do this is solve first the shorter leg by way of the formula longer leg is equal to square root of 3 times the shorter leg. There. This is the way to do it. Okay, longer leg is square root of 3 times the shorter leg. Now we're going to substitute this value here. Longer leg is given 3 square root of 2 equals square root of 3 times the shorter leg there. And so we're after the shorter leg here. Therefore, we're going to divide by this number. Okay, remember in algebra, the coefficient, numerical coefficient of the variable will be used as divisor. So we're going to divide both sides by square root of 3, like this. And this cancels out. Shorter leg is equal to 3 square root of 2 over square root of 3. And again, if you have a square root at the denominator, it says there it's not simplified. So we're going to simplify this by rationalization. So we're going to multiply by square root of 3 over square root of 3, so that the denominator will have a square root of 9, and that will be reduced to a 3. And so we continue like, let us exchange first the positions of the number and the variable. Okay, there. Okay, now we multiply this by square root of 3 over square root of 3. And so this gives us square root of 9 at the denominator. And we have on top 3 square root of 2 times square root of 3 is square root of 6 there. And so this continues like 3 square root of 6 over square root of 9, which is 3. And the 3 divides. Finally, our answer here is simply square root of 6. There. And this goes to our shorter leg there. So that means, going back to the figure, this is square root of 6, the y. There, square root of 6. Now we are ready to get our hypotenuse. Okay, let's go back to our formula for hypotenuse. In this 30, 60, 90, the shorter leg times 2 is equal to the hypotenuse. So hypotenuse is 2 times the shorter leg. There. So this will be h equal to 2 times the shorter leg, which we already know, and that is square root of 6. There. And so our h is 2 square root of 6, which is also our x. 2 times square root of 6. That must be our hypotenuse there. And our y, okay, our y, which is the shorter leg, is square root of 6 there. Okay, this goes to our number 7. Okay, this goes to our number 7 there. All right. So I hope you were able to see the solution. Okay, and we shall verify it in the other side. From the problem set, That goes to our number 7 there. So we have 2 square root of 6 for x, which is the hypotenuse, and the y is square root of 6, which is the shorter leg. Exactly what we did on the other side. Final example. All right, number 8. So we did actually 4 examples for each. This must be the last one there. And nothing follows number 8. So we'll just complete this. Let me just use the other side of the paper. Okay, this is the last problem. For special right triangles, let me get the data. Okay, we have the drawing of this special right triangle. This is 60 degrees. This is 90. And we have the shorter leg y, unknown. We have 7 square root of 3. That must be the longer leg. That must be the longer leg. And this is x. And that's it. That's all we have for number 8 as given. We shall use the paper for the solution. Okay, let's go back to that screen over here. Okay, here's number 8. Let's examine what we have as given. We have 60 degrees. We have a right angle here. That must be the 90. And this must be the 30. The 30 there. And so we are quite sure if this is the smallest, this must be the shorter leg. And if this is the 60, then opposite to that is the longer leg there. And of course, the x here is opposite the 90. That must be your hypotenuse. Yeah. You have to start examining the given before you solve it, so that you know which formula you're going to use. So what we have here is the longer leg. We shall solve first the shorter leg and then solve the hypotenuse. So knowing the longer leg, we shall begin with the given. We shall adjust the screen. Okay, let me just make it smaller. Let's make this one smaller. Okay, let's do it that way. Okay, all right, so we have here the given, which is the longer leg, and this is 7 square root of 3. That's the longer leg, and we know the formula for the longer leg. That's equal to square root of 3 times the shorter leg. This is the formula. So if we're going to use this, we substitute the 7 square root of 3 right here. Okay, so this is 7 square root of 3 equal to square root of 3 times the shorter leg there. So one equation, one unknown. Okay, we can easily solve the shorter leg by way of division. So 7 square root of 3 is equal to square root of 3 times shorter leg. We divide both sides by the square root of 3. And this cancels out. We have the shorter leg. This also cancels out, equal to 7. There. And so shorter leg is equal to y is equal to 7. So this is equal to 7. There. Y is equal to 7. There. Next, we're going to solve for the hypotenuse. Hypotenuse is 2 times the shorter leg. And we now have the shorter leg, that's 7. Okay, so hypotenuse is 2 times the 7. That must be 14. And this goes to the x. There. So x is 14. So the two answers are 7 for the shorter leg and 14 for the hypotenuse. And let's verify that. We should be able to check on the answers on the other side. Let's go to the problem set screen. And let's verify. Okay, let's verify it. There. Hypotenuse is 14 and the shorter leg is 7. And that's for our discussion for the special right triangles. I hope you were able to learn something from the examples and be able to do your ingenuity activities. All right, class, I'll see you in the next lesson. Bye-bye.